That's what I think.
Okay.
Yeah.
Hey, what did you get for? I thought I put all my
Well, I did an extra down, so I did 142, and I divided it, 142.4, divided by 89.
Because I mean,
Divided by 100. I put it 89.
I think like would go in. No, I'm really bad about that. Why? You realize, like, how do you not say it like that? You don't, you lock on,
All right, hopefully the first two weren't too bad, because they were more along the lines of what we've been looking at already. Other than on part A, they did say that I was going to decay at 6%, so you have to be careful with that. So if that does happen, if I'm going to decay 6%, what's that mean my multiplier is going to be or my B value is going to be there? B? Yeah, because if I lose 6%, I get to keep 94%. So I'm going to multiply by 0.94. So in terms of an equation, depending on what variables you used, you might set up something like that. Well, then you had to answer the question. Well, the question said, well, how much or how big would the sample be after 1 year? Well, again, you had to be a little bit careful because this 6% was how often? Every week. So what's my exponent going to be? If I'm looking for a year. Yeah, 52. So when you plugged in your x value, since this was in terms of weeks, your x value had to be in terms of weeks. So you end up with a little over 4 grams, I think. 4.005 grams at the end of the year. Part B, kind of the same idea as far as it's fairly similar to what we have been doing. You had 45 members. The enrollment was going to increase by 30%, and they wanted to know how many they'd have at the end of 5 years. So if we're increasing 30%, we should have had 1.30. In this case, can I just plug 5 in? Yeah, we're talking about that yearly amount. So after 5 years, we'll know how many members we'll have, and in this case, we should have been around 167. All right, hopefully those two aren't too bad. C and D were kind of variations, though, of some of the things we've been doing. So in part C, they talked about Barbara making that bad investment. She didn't earn interest. She actually lost 11%, and that happened each week. And after 1 week, she was down to $142.40. So they want to know how much money did she start with. And then after that, they want to know if she doesn't withdraw her money, how long before she'll have less than half of what she started with. All right, so let's start with, first of all, how did you figure out how much money she started with on there? Austin, what did you do?
Well, I made like an equation.
Okay, so what was your equation?
So it's 142 $140 is equal to A, because you don't know the starting value,
Okay.
times 0.89.
And why 0.89?
Because it's decreasing by 11%, which is 18%.
Okay, and why the 1?
Because it's actually.
Okay, so if we think back to original equation, or exponential equation, we talked about this is really the zero value or the initial value. The B value is the multiplier, which we actually know. This is usually the amount of time or the amount of months, weeks, days, whatever. And then we're going to have any value in this case. So we kind of knew different pieces than usual. Because usually we know where we started. We know the multiplier. We want to figure out where we're going to finish. So it's a little bit different. So how are you going to solve that equation? Because our goal is to figure out A, right?
Well, we know that 0.9 is the first, is 0.89.
Right.
So then that's 0.89 times A, so then I divide by 0.89 with like 160.
Okay, so I can just divide both sides by, in this case, it worked out nicely because it was just 0.89 to the first, so we can just divide by 0.89. All right, so the equation I'm going to work with is going to be this one. I now know the initial value is 160. I still know my b value is 0.89, and now I have that to the x power. So the follow-up question was, well, how long until she's going to end up with less than half of what she originally had? Or if we think in terms of starting with 160, when's she going to have less than how much? 80. So really what I'm trying to do is solve this equation. To figure out when she's going to be less than a half, maybe we start out by figuring out when is she going to be exactly at a half. So I'm kind of trying to solve this equation. Because if I know when it's half, then I'll know, again, right after that, it's going to be less than half. How would I solve something like this, though? There are some options. Just one way to do it. How did you come up? You may not have written this equation, but how did you come up with when they're going to be less than half? Would you do like
I
that?
just kept plugging numbers in.
Nothing wrong with that. We can guess and check, do some plug and chug, see what happens.
I got it on my table, I got it on my calculator and did the table thing and like 80.
Okay, so once you made sure you got to 80 or less, then you knew you were in good shape, right? So that's a good idea. Put the equation in, look in your table, because that has values in there.
Would you divide by 160?
Maybe I try to do it algebraically. If I did divide by 160, I now have a half over here. I have this over here. How could I solve that? Not quite, because that's the base. We could do the x root, but I don't know what x is, so that doesn't really help me. So I kind of get stuck there. Well, eventually we'll have some methods for that. We'll have a way to solve an equation like this. But right now, it may be going back to the table, seeing where that's going to happen. Maybe it's going to go back to guessing and checking, just plugging in values. Especially on this one, because they talked about full weeks, so you'd have whole numbers on there. There is one other thing that we could do on this, on the calculator. If I looked at this equation here, and I wanted to figure out the solution to that. Here's something else I could do on the calculator. My calculator will work. You know? If that is really going to be equal, if the left side is really going to be the same as the right side, I can really set up two equations here. I could set up one that says 0.89 to the x power, so that's the right side. And I want another equation that's going to be the left side, so I'm going to say that's equal to a half. Or I could have gone back to the original one if I wanted to. If I have these two separate things, but I want them to be the same, if I were to look at the graphs of these two, if I want to know when they're the same, what would I be looking for? Right? Where they intersect, right. And I can see that they do cross here, but I can't really see exactly where that's at. But luckily, the calculator will give me the intersection of that graph. Above this trace button, it says calculate. So if I hit second, and I hit that trace button, we have an intersect option on there. So I'm going to select intersect, and I kind of get a spider-looking thing there. So I'm looking for the intersection of these two. It asked me for the first curve, and it gave me the first equation. So I want that one, so I'm going to hit enter. It asks for the second curve, and it gives me the second equation. So I want that. I'm going to hit enter. And I hit enter a third time, and it actually gives me the intersection point. It it tells me the intersection is at 5.94. Now, remember, that's when it equaled a half. We want to know when it went below a half. So we'll probably just go ahead and say, well, it's going to be at week 6, which is probably what you got when you did your density checking before you looked in the table. So we'll use that as a method as we kind of continue through with some more exponential stuff. All right, what about the last one? The last one was the one where he got into some debt at $285 worth of debt. He had 18% annual interest, but it was compounded monthly. And they want to know, first of all, how does this debt grow as time passes? Or in other words, how much are they charging per month? It's probably a better way of asking that, percentage-wise. And then secondly, how much would he owe at the end of the year if he had a no payments for 12 months feature on his credit card? So let's start out with, how much is he going to pay per month? Well, if he's getting 18% annual interest per month, would that end up being percentage-wise each month? 1.5. So he's getting charged 1.5% each month. Well, his debt is $285. Each month, he's getting charged 1.5%, so that'd be 1.015. And he's not going to pay anything until the end of the year or 12 months. So we're going to look and see how much is left at the 12-month mark, or how much it cost him. So once you punch that in, it should have been about $340. So that's kind of a lead into chapter 2 that we're going to begin next week, where we're going to have different pieces of our exponential. I think we're getting pretty comfortable with, here's the starting value, here's the percentage, solving those type, but now we're going to get variations of those pieces of information. So we'll kind of build on that as we go. Like I said, a couple problems from the homework that I wanted to go through just to make sure that we understood those. And then I'll look through them and see if there's others that we need to talk about. I thought 73, I don't know that it was a tricky one, but the way they explained it, I thought made it a little bit trickier. 73 was the one where they started with this expression, like what we worked on the other day. But then they talked about dividing that expression up into different pieces. To me, that made it more confusing than helpful. So if you did those steps, that's fine. But if I were attacking this one, I would think back to what we talked about on Tuesday, where we said, well, we've got to get rid of parentheses, we've got to put like terms together, we've got to get rid of negative exponents. Well, we don't have to worry about parentheses on either one of these. I would probably start with the negative exponent part. So if I were doing this one, I would start out just by rearranging things. So that 3 would stay put, the x squared would stay put, but I'd move that negative 3 down to the denominator, make it positive 3. Down here, I've got x and negative 1, so I'm going to move that up. And then I have positive 2, so I'm going to leave that. And now I combine the like terms. So for this one, you should have ended up with 3x cubed. And then the denominator, we have y to the 5th. So if you split it up like they ask you to, that's fine, but I'm not sure that's really that much helpful. For the last one then, same idea, rearrange some things. The m squared is positive, so it stays put. Same thing with p, the q would move down to the bottom. Do I move both of these? Yeah, just the m, because it's just the next one on the m. So now I have m squared. This is positive, so it stays put, so does the q. And now I put things together. So I've got m squared and m squared. I got p over p, so that's going to cancel. And then I've got 4q to the 4th. That should have been a simplified form. So we'll continue to work on those and simplify those. Another one that usually I have questions on was number 76. It was the one with the dairy producers. So they talked about the cows that produced enough milk to fill 4,800 gallon tanker each day. They said the milk is then hauled to a processing plant. They put it into smaller storage containers. Use those to fill gallon jugs. They go to the local stores. The containers each hold 600 gallons of milk, and they wanted a graph to show that. So here's the graph that would work for this situation. The reason that this one was going to be a step graph, if you think about it, started out at 48, or could fill a 4,800 gallon tanker, but each storage container was going to hold 600 gallons. So initially you had enough to fill 8 of the tankers, or 8 of those containers. But as we filled up each one there, it's going to then max out, and then you got to go to the next one. And then we're eventually going to run out. So that's why it's a decreasing step function on that one. So hopefully you noticed that one was discrete. Then the last one I want to talk about, I'm not going to talk about both parts, but this leads into what we're going to do today. On number 85, they want us to find a possible exponential equation in this form. And in order to find it, they gave us a couple pieces of information. For instance, in part A, they said the initial value is 2, and then it passes through the point 3, 128. All right, well, when they tell me the initial value, what are they telling me in the equation? Which part? Yeah, so I already know the A value. So in order to write my equation, all I need to know now is what the B value is. Well, we got to have some strategies for that. Well, you can do some different things. One thing you might think about, though, is if my initial value is 2, I don't know the first value or the second value, but I do know the third value. It's 128. So we had a table kind of like this the other day. What you might think about is, well, first of all, how did I get from the 2 to 128? What did I multiply by to get from 2 to 128? Sorry?
By P.
Well, I mean, just total from 2 to 128, what do I multiply? 3 times, but what was the overall value? Like if I just said, how do I get from 2 to 128? What did I multiply by? 64. Now I had to do that 3 times, right? I had to do something 3 times to get to that total of 64. Or in other words, I need B cubed to equal 64. Well, B cubed is 64. What was our B value? 4. And now I know the rest of my equation. So maybe a table would be helpful in order to find that. We're going to talk about some other strategies today that you might use, especially if you don't have that initial value given to you, that you might have to use in order to find your equation. All right, so that was kind of a lead into what we're going to do today, so that's what I want to make sure you kind of had an idea of that. All right, here's what I'd like you to do to begin with for our new part. This is actually a review, but it's going to lead into our new part. I've got 2 situations. The first one, I want you to see if you can find the equation of the line. Now we're thinking about lines. We're going to write it in slope-intercept form. So y equals mx plus b. And we're given the fact that the slope is equal to 3, and we also know it goes through that point, 519. The second one, same idea. This time we're going to find the equation of line, but all we know is it goes through those two given points. All right, so both parts, you're trying to find the equation of the line based on some different pieces of information. All right, let's go ahead and move into our groups. Compare your answers, but more importantly, I want you to compare strategies that you used. We're going to see if we can maybe bring these strategies over to exponentials and looking at their equations. For this first one, I'm going to ask the group in the back there, what was the strategy that was used for that first one? Everybody may not have done the same thing, but I'm guessing you probably did about the same thing.
I substituted the 1 into that would be 19 equals 3 times 5.
And so if I went back to this, really the two parts I need to find the equation were the slope, the y-intercept, and we're lucky enough to have the slope, right? So you could plug that in. So really the key was what was y-intercept. And we could do that by plugging in that coordinate. So once you did that, you should have found out your v value was 4. So your equation was 3x plus 4. Okay? So if we're lucky enough to have one of the two parts, then we just plug in that part, and then you plugged in the ordered pair. Let's go back to that problem I did a second ago. When we did this exponential, I was lucky enough to have one of the two parts. I had the 2 there. Could I have used the same strategy we just did and say, okay, if I know one of the parts, now I'm going to plug in the coordinates. In other words, could I plug in 128 for y? I knew the 2. I didn't know b, but I knew x was 3. Is that an equation I could solve? Yeah. Because I solved it by dividing by 2, which is 64. And that equation sounds familiar because that's what we did right there. We have b cubed equals 64. And we could have gotten back to that same equation. So even though we're dealing with exponentials now, that idea that we used for line could have been used for exponential. All right, what was the strategy that you used on number 2? What did this group do here for number 2?
We did like the same thing as number 1. We wrote an equation.
Okay, how did you get there?
To find the slope, we did y2 minus y1 over x2 minus x1, so the negative 6 minus 3 over 5 minus 2.
Which ended up being?
Negative 3.
Okay, so your first step or first goal was finding the slope. All right, and then what did you do?
And then I did 3 equals negative 3 times 2 plus 3.
Okay, so we basically are back to what we did on the first one, right? Once we knew the slope, so we could plug in. Which point did you use?
2, 3.
Okay, so you used this, you plugged in your slope, plugged in your x value, found your b value, all right, which was?
9.
So you got this equation. Okay, and that was probably the tried and true method that most of you learned before. Find your slope, plug in a point, then you got your equation. Anybody try this? I know my goal is to find y equals mx plus b. When I have this ordered pair, I really have an x and a y. So if I plug 3 in for y, I don't know m, but I do know x, it's 2. And I don't know b. So maybe I write that equation. Then I go to the other point. Well, that's an x and a y as well. So my y is negative 3. I don't know m. My x is 5. And I don't know b. So maybe I could just use this system of equations. Now, it may be better to write, instead of m times 2 and m times 5, it may be easier to work with if I say 2m and 5m. What might be a good strategy to solve that system of equations? Is this a good elimination, good substitution?
Well, if you, on the first equation, you subtracted 2 on the other side, again, equation is equal to b, and then you could substitute it into the other one.
Okay, so that's a strategy I could use. I could do substitution.
You could subtract the bottom one also.
I could also just do straight to elimination and subtract them. Let's say I did do that. Well, I'd have 3 minus negative 6. I'd have 2m minus 5m. I'd have b minus b, which would cancel. So if I divide it by 3, I get negative 3. So I've got my slope. What do we usually do next? Plug that in. So we take this, we plug it in, and now I've got that equation that I've used before. And now I have my b value. I can find it at least. I can find my b value. So another strategy that you can also use, because we know we got to fit that model had some information, so I could just plug in the information that I had. Well, we're going to kind of use these ideas and see if we can carry them over to exponentials. Here's what I want you to try to do with your group now. I want you to try to find the equation of an exponential function that passes through those two given points. So now we're trying to fit this equation, y equals a times b to the x. So now I got to know what my a value and b values are going to be. All right, so talk to your group members, see if you can come up with some sort of strategy. Think back to those things we did with lines, because some of that can apply. The goal is to figure out what's A and what's B. So I can decide how that's going to happen.
I have a question about the calculator. So I know on my old calculator, if I want to do, if I was here, yeah, root 4. So here I see that there's just, how would you do it?
I put 4 in first.
Thank you.
I had a good calculator question. On the graphing calculators, if I wanted to do, say, the sixth root of something, I've got to type in the 6 first. I'm going to hit the math button, and then there's an X root option, number 5. Now, depending on your calculator, some of them will go ahead and put that 6 there. Some of them will have the 6, and then it'll say X, and it's basically saying the 6 goes where the X is. And then you can type in whatever So if you're ever doing the root, on most of the calculus, at least you have to put the root in first, then hit the x root, which is upper bound.
I got 16 people AB squared. And I also got 206 people AB. And then I solved for A on both of them. I made it so like A is real low. So like I divided like 256 I divided by A. And I got A equals B squared over 16. A equals B6. Did you get it? Using the table?
Yeah. I got the two, but I think I.
And then I made that. And then I applied 16 B6.
We'll talk about strategies, but if you've done it correctly, you should get that for an equation.
Why 6 times 6? What did you do that to? Divided by 16 on both sides. So it's B6 equals 6 squared. Then I 3
Right.
divided by B squared.
Then I did out with the value. But then I did,
And I did the fourth derivative of the
4, then it was 4 times starting value. And then I just figured out.
I got it. We have to not make off.
I just did like the four.
No, it's just hard to know what to like where to go. And I'm like on the higher team. I don't think that is. So
I mean,
it's
I
on
only
like
got
slow.
60. I don't know. He was like, what's the problem?
That's like you're up there, guys. Yeah, so people on some of the years they all started. How would I play the
Bro, did you see my camera?
So when you play that, I think it's a search on the store.
Very cool.
We have
had a lot better team. We couldn't like throw us games. And then even if they missed the shot, we can't get the rebound. So we're all like, the tallest guy was like 3 inches taller than me. And he's like, so he doesn't have a center. Like our dude that was good at rebounds, he's short. So like he couldn't get it. So we didn't have anyone tall, so we couldn't get a
First one, set.
Oh, so you're not on the team? Sometimes about swatted me from 6 feet away. Yes.
On what? I said I had these
Wait, how do I cheat? Oh, so you guys just have to pay the revenue?
I'm so happy.
It's only good.
I put the year on last year's. Like, I'm last year.
Well, I know like in summer, like they put like the yellow.
I just took the point that they,
Right.
yeah, I did the table and then I noticed that
Sorry, I don't know
4 points away.
certain sports.
So I wanted to see
I know.
if they were,
I have plenty of time.
and since I knew it was, the Y was 296,
I watched.
and then the X was
My
6.
dad has like season tickets to football, so I go to like the games.
TX was 6.
So
Yeah. So I was like, well, it was more
But they're
spaces.
not fun because you don't get to see the
Hey,
attention.
what-
You're just running, not getting any yardage.
So that gave her feedback, we had to do it right.
Well, every now and then.
I just plugged it in
We had somebody.
yeah, I don't know.
It was like super fast. You could watch it and I could run like 60.
Yeah, I plugged that in along with the X and Y value. And then so
We wore them to the gym.
It's really the same thing we did back.
We won.
And one of them.
So, yeah. Only the rest of them.
Yeah.
She did correct us.
How many groups use the table? No, if you saw this. You saw that? Come on. All right, that was a good strategy.
Where you get like pitching. My plays are so inaccurate and like I always like either overthrow it or it slips out. Honestly, I probably would.
Austin, yeah.
Good way of faith.
Yeah.
Yeah.
I kind of wish I was this one.
Linebacker.
All right, so a lot of you did the table. Nothing wrong with the table there. And that's pretty good because these were fairly close to each other, the 2 and the 6, so it wasn't too bad to figure out. I'm going to show you how you can maybe use that strategy I showed you with a line in case I have a situation where maybe they're not very close together. So when I did that system of equations earlier, I said I know I need to fit a type of equation, which was a linear equation earlier. But all I know is x values and y values. So I'm going to take one of the points. I'm actually going to start with this one, and I'll show you why later. But I'm going to plug in the y of 256. I don't know a and b, and I'm going to plug in the x of 6. Then I'm going to take the second point and do the same thing. So I'm going to plug in the y of 16. I'm going to plug in the x of 2. So now I have a system of equations. Well, earlier we just subtracted them to get rid of the b's. In this case, though, I have a times b. So I don't want to do subtraction. I'm actually going to undo that by dividing the 2 equations. So I'm going to take these 2 equations and I'm going to divide those 2 equations. Well, to divide them, I'm going to take them piece by piece. So I'm going to do 256 divided by 16, which those of you that did the table did that step as well. What did you get when you took 256 divided by 16? 16, right? What's a divided by a? 1. It cancels out. That's what I wanted, was to get rid of something. What's b to the 6th divided by b squared? B to the 4th. And those of you that did the table found out there were 4 steps that you had to go. So it's like doing b to the 4th. So we can kind of get to the same equation you did for the table, just another way of thinking about it. Now, the reason I put this one on top was for a couple reasons. One, I wanted the larger exponent on top so I could avoid negative exponents. And then secondly, for this specific problem, it gave me a nice neat whole number. From this step, that's where that root's going to come in. So I do the 4th root. So that's where the b value of 2 came in. Well, with systems of equations, once I know one, we just plug it in, we find the other one. So once I knew b, I could plug it in, and now I can find a. So 2 squared is 4. When we divide that, that's how I get the a value of 4. So just another way of thinking about it. There's nothing wrong with the table. And in fact, when you do the table, your strategies or your steps almost are the same. But attacking it this way, where we plug in the x and the y, makes it nicer, especially we'll start throwing some negatives in there. We'll start throwing some situations where maybe the b value isn't nice and neat. So this strategy might be helpful when that does occur. So what we should be able to do, and what we'll be working on, is finding the equation of an exponential given different pieces of information. Maybe we know both points. Maybe we know the initial value and only one point. But whatever information we have, we eventually have to find that exponential equation for that. All right, there's one other thing that I want to go through here today, but I'm going to wait a few minutes because I'm going to have you get started a little bit on the homework for Monday. A couple things about Monday, actually, but I'm going to start out with the homework. So first of all, these are the problems that I'd like you to complete for Monday. And I want to give you some time here in class to get started on those. But also on Monday, we're going to have a quiz that covers some of the material, not only from Appendix B, but also Appendix A. And remember, that was figuring out arithmetic and geometric sequences. being able to find the equation of arithmetic or geometric sequence, whether that be explicit or recursive. And then we had some other general things that we keep practicing from chapter 1, things like factoring, things like solving system of equations. There could be a little bit of exponent simplifying, maybe not as involved as some of those longer ones that we did yet Tuesday, but some basic simplifying exponents. But that'll be on Monday. We'll do some reviewing first before we take the quiz Monday to kind of give you an idea of some things that you need to be ready for. But for right now, I'd like you to get started on some of these problems. I haven't really given you a whole lot of homework time lately, so I'm going to try to give you a little bit of homework time right now.